single replacement reactions, okay? That's what we use this for. All right. To determine which reactions will occur and which will not. All right, that's what this tells you, because not all reactions happen. Shh. So, at the top, you have this in your data booklet as well. 14. These are the most reactive. And then it decreases in reactivity going down. Okay? So lithium is going to be more reactive than potassium, than sodium, than calcium, magnesium, blah, 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 blah. Okay. Down to least reactive. Okay, so a reactive metal will replace any other metal, because metals replace metals, that is lower in the activity series. So for example, you just look at this. Potassium and say zinc. Potassium will replace zinc because potassium is more reactive. All right? The higher up will kick out the other one that's lower down. Okay? Kids. So basically all you're doing is you're looking at this. You're given a reaction. You have to tell me if a reaction occurs and if it doesn't, and what would be the products. So let's look at magnesium chloride. Let's actually write the chemical formulas. What's the charge on magnesium? Data booklets, people. +2, thank you. So magnesium is +2. What's chloride? Chloride. Chlorine is -1. So magnesium chloride is MgCl2. Plus hydrogen, which is H2. So, does a reaction happen? No. So you just look at magnesium and look for hydrogen. You look on your data table. Here's hydrogen right here. Where's magnesium? Magnesium's right there. Magnesium is higher. So hydrogen cannot boot out the magnesium. So you just say no reaction. Okay? All right. Hydrochloric acid. What's hydrochloric acid? HCl. Plus magnesium. Now, if you just looked at what we have in the previous one, we have magnesium and just hydrogen. Okay? Hydrogen isn't bound to anything, it's H2. But hydrochloric acid, HCl, there's a special caveat. So if you look right above it, metals from lithium to lead. So lithium is lead to lead. Will kick out hydrogen, displace it is how chemists would say it, from acids. Okay? So HCl is an acid, right? Because it starts with a hydrogen. So the magnesium is going to kick out the hydrogen, and you're going to get MgCl2 plus H2. Okay. It's essentially, look at this is MgCl2 plus H2. This reaction going this way doesn't want to happen. All right? But when magnesium's by itself, it says, I want to get to this stage. Okay, because I'm really stable and this is stable and I'm happy at this stage. So the reaction goes and then it stays there, right? Magnesium chloride is very stable. Potassium chloride and iodine. So potassium chloride is KCl. Iodine is I2. So now, what are the metals in this reaction? There's only one, right? Potassium. So now we're just looking at a non-metal. There's an activity series for the non-metals though, right? Right here. Fluorine, chlorine, bromine, iodine. Will this iodine kick out chlorine? I.e., is iodine higher than chlorine? It is not. Iodine is at the bottom, essentially, and chlorine is right there. So iodine tries to kick out chlorine, and chlorine goes, no, this isn't happening. So this is no reaction. Potassium bromide, KBr. And fluorine, F2. Will that reaction happen? And if so, what are the products?
Potassium chloride plus bromine.
Yeah. So you just look at the two nonmetals, bromine and fluorine. Go up here. Is fluorine higher than bromine? It is. Fluorine's like the most reactive. So it will kick out any bromines that are there. So you're going to get KF plus Br2. We're not worried about balancing these right now. Okay. So non-metal replaces a non-metal. All right. Hydrochloric acid and silver. HCl plus silver. So what does this silver want to replace? It wants to replace the hydrogen because silver is a metal, right? And metals are always written first in the reaction. So we're looking at silver and hydrogen. Is silver higher than hydrogen? No, silver's right there, hydrogen's right there. So the hydrogen says, not happening. So no reaction happens. Is that okay? All you do is you look to see what's replacing what. Whatever's higher on the table, if the element by itself is higher than the corresponding element, whether it's metal or non-metal, in the compound, it will replace it. If it's lower, it does not happen. The reaction doesn't happen. Okay? Did you do these questions? Yeah? I'm getting like some nods and some no's. So we don't need to do these? You've done all these? No? Yes? You didn't finish them. Okay.
Me personally,
All right. I'll give you 4 minutes to work on those questions quickly if you haven't done them all. I don't just want to burn through this and forget it. Okay, so if you have a double replacement reaction, okay, then you have to look at solubility, all right? Because sometimes you form a solid and something will fall out of solution, which we call a precipitate, okay? In your data booklet, you have this solubility table, solubility of common compounds in water, all right? It will tell you if things will form a solid or not. So if we look at NaCl, Is it soluble or not soluble? Okay, what they would call low solubility. All right, so sodium chloride. So you go to your data table, the top here. Oops. We got lithium, sodium, potassium. Basically, all the alkali metals are soluble in everything. Okay. All right. Doesn't matter what they bond to, they will be soluble. All the alkali metals. So we're going to get soluble. Next one is calcium carbonate, CaCO3. You go to the data package. You look up either calcium if you can find it, or you look up carbonate. So carbonate. Here's carbonates at the bottom here. Okay. CO3. Now it says with all the alkali ions, hydrogen and ammonium. The alkali metals are the first row, right? Which we just listed. Potassium, lithium, or hydrogen, lithium, sodium, potassium, blah, 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 blah. All right. We are bound to, what are we bound to? Is it calcium? Yeah. Calcium. If calcium is not on this list, then it means it's here. That means it is not soluble or low solubility. Okay. And that's how you use this table. You essentially just look up each one of these things on the table. Okay, so we pick another one. Let's go to copper 2 chloride, or sorry, copper 1 chloride. Okay, find copper on the data table. Why is this not working? Or is it chlorine? Okay, so here's chlorine right here. All right. Copper 1 was the one that we had. Copper 1, Cu plus 1, is low solubility. Okay, so that is going to be low solubility. If I said CuCl2, that's copper 2, right? Yes? Copper 2 is not here, which means that would be soluble. Okay, so you have to pay attention. When it's multivalent, you have to pay attention to the actual valency of it. Okay, if it's copper 1, copper 2, whatever. All right, iron, same thing. So just be careful with that. This would be low soluble, or that would be soluble. All right, let's just do a couple of these predicting products. So, because
there's like low solubility and solubility. Is there like a high?
well, they're defining what's low solubility because everything will dissolve a little tiny bit, but you don't really see it. Do you know what I mean?
Yeah.
Like plastic dissolves in water, but for all intents and purposes, it's so low. Although you're ingesting it, so then there's other complications with that. But you sort of understand. You wouldn't see it precipitate, right?
Yeah.
That's why they say low soluble, because then they define what the level. And if you look at that table, they're defining soluble as greater than 0.1 moles. And you have to give the temperature, because if you increase the temperature, it becomes more soluble. Solubility increases, I should say. So. All right. Let's just do a couple of these. So, do number 3. All right. Aluminum sulfate plus sodium phosphate. First of all, what do you have to decide? Or sorry, okay. Aluminum will kick out the sodium. So to predict your products, this is something we should actually work on. What's the charge on aluminum? It's +3. What's the charge on the phosphate? It's -3. I'm going to ask you to do this on a test, predicting products. So it's Al plus 3, PO4 plus 3. The sodium is going to bond with the sulfate. What's the charge on sodium? It's +1. Sulfate is all in your data package, is -2. Okay. So then to get the actual chemical formula, you do the crisscross thing, right? So if I'm going to actually write the formulas, it's going to be Al. And if it's 3 and 3, they kind of go away, right? You always put it in lowest terms. So this is going to be AlPO4 plus Na2SO4. So you get those. Those are your products. That's the way I want them written. I want them written like this. Okay. Then you ask yourself, is one of them not soluble? Okay. So the first thing, you're going to have to look at both. But if you remember, anything that bonds to an alkali metal, is it ever going to be insoluble or low solubility? If there's an alkali metal, sodium, potassium, lithium, it's always soluble with everything. Okay? So you don't even have to look at that once. All you really need to do is look at the aluminum phosphate. So back to our table. Aluminum or phosphate. Phosphate. There's phosphate at the bottom. Right here. PO4. It is soluble with all alkalis, hydrogen, and ammonium. Is aluminum in that group? No, that means aluminum is in this group, which means it is low solubility. So in your chemical reaction, you would write solid. Okay? And then we would call that a precipitate. Okay, does that make sense? Yeah. Sure, that's exactly what every teacher loves to hear. Sure.
I mean, it's kind of like the same thing as you said. It's just good enough.
Well, that's demos. That's different. And I'm a professional, so. All right. That's where you got to yesterday, isn't it? Is that where you got to yesterday? And then he gave you questions out of the book or out of Habden that nobody did?
I did too.
He didn't? Did you do these?
He gave us all the answers.
He just gave you all the answers? Okay.
That's the way.
All right. Okay. Before we do the new stuff, we have to practice this. So I need you to do page 118, number 67. You can do it right on this sheet. Okay. Is there 50 billion? Let's look up.
50 billion.
That's not exactly 50 billion.
I don't know if you round, yeah, I think